Section 2, question number 17. Complete the table below for A, the equation y is equals to 6 plus x minus x squared, taking the integral values of x in the range that is given from -3 to 5. So we fill this table. So you can see some values are already filled. So you just require to fill some of them. So we start with the first column when x is -3. So remember we are adding 6. Then we add x. X is -3. Then the other one is -x squared. So if x is -3, so -x squared. -x squared will be negative. So negative. Then x is, just writing this one as the first one for the purposes of maybe clarity as we move on. So when x is -3 and you want to take -x squared, that is how you do it, and this will give -9. So here we have -9, and then we can fill this. So 6, so we are adding. I'll put a boundary here so that you don't get confused where we're adding from. So I'll put a boundary there. So remember we're starting to fill the values from 6, subtract 3, that is 3, then 3 subtract 9, that will be -6. Then when x is -2, 6 subtract 2, that is 4, 4 subtract 4, that is 0. The other one, when x is -1, 6 subtract 1, that is 5. And then -x squared. -x squared, this one will be -1. So we have 6 subtract 1, that is 5. 5 subtract 1, that is 4. It is already given there. So the other one, when x is 0, this one will be 0, and this one will be 6. And when x is 1, that is filled. So when x is 2, this part of -x squared, that will be -4. So we have 6 plus 2, that is 8. 8 subtract 4, that is 4. And then when x is 3, 6 plus 3, that is 9. 9 subtract 9, that is given. Then the other one is -x squared. -x squared will be -16 when you have x as 4. Then the last one for this one, I will correct something here. When x is 5, -x squared will be -25, not +25 as indicated there. That will be -25. So you have 6 plus 5, 11. 11 subtract 25, that will be -14. So now we filled the table. Part B, on the grid provided, draw the graph of that function in the range given there. So let me look at the graph. So the graph is, make sure that when you're choosing the scale, you can start by looking at the x. The x values runs from -3 to 5. So for that one, I can use 1 centimeter to represent 1. Then for y-axis, the y-axis, we have the largest value. The largest value there I can see is 6. And then the smallest is -14. So you can see these will be 20 values. This is how you choose the scale, by simply getting the largest value, subtract the smallest values. So the y-axis will have to accommodate 20 values. That is on the y-axis. On the y-axis. So for 20 values, this one, since you can see you have the largest value being -14, that's the smallest value being -14, and we have the largest as 6. So you need more space on the negative side of the y-axis, and to accommodate 20 values, you need to use a scale of 1 centimeter to represent 2 units. 2 units will be okay. So with that in mind now, we can draw the axis. So let me draw the axis. So that is the, and then for this one, because I don't need be okay. So this will be the x-axis, this will be the y-axis. So this one is 0, this one is 1, this one will be, so this one will be 1, 2, 3, 4, 5, 6, 7. And then we have negative, we have negative 3, so negative 1, negative 2, negative 3. Then let me see whether this one, for the y-axis we have 2, so this is 2, 4, 6, 8. Then you have negative 2, negative 4, negative 6, that is 1 centimeter represents 2 units, negative 8, negative 10, negative 12, negative 14. Now having that now, we can now proceed and plot. So the first one, when x is negative 3, when x is negative 3, y is negative 6. So negative 3, negative 6 is here. Then we have when x is negative 2, y is 0. There we have. And then when negative 1, when x is negative 1, y is 4, negative 1, 4, like that. And then 0, negative 6, the other one, 0, no, 0, 6, not 0, negative 6, 0, 6, 0, 6, and 1, 6. Then 2, 4, 2, 4, and then 3, 0, 3, 0, then 4, negative 6, 4, negative 6, and then 5, negative 14. 5, negative 14 is here. So now you have all the points. So you have the first one, the second one, you have all the points there. We've plotted them correctly. Now, try to draw that the best way I'll be able to do it. So after that, you can write y, this is the function, y is equals to, write the equation of that curve, is y is equals to 6 plus x subtract x squared. Now after doing that, you can go to the next question. So using the same axis, draw that. We've done, we're supposed to, let me see the first question. Okay, on the grid provided, we've done that. So for this one, for the scale, you get a mark. For plotting, you get a mark. And then for the small curve, you get a mark. So the next one, using the same axis, you're supposed to draw the graph of y. Graph of y is equals to 2 subtract 2x. We draw, this one is a straight line. So to draw that, you need at least 2 points. At least 2 points. So I can choose the first one when x is 0, any 2 points. When x is 0, you have y as 2. And then when y is 0, when y is 0, x will be 1. You're simply substituting these values of x and y in that function. So you have these 2 points are enough for you to draw a straight line. So 0, 2, 0, 2, pass through there, and then we have 1, 0 pass through that point. So now you draw straight line. So you join these using a straight line. So that is a line. So you can extend it. So you can extend it to that is the line. So use a ruler to do this. I'm using the digital tools, that is why you can't see a ruler here. So use a ruler to join these 2 points, 0, these are the 2 points. We have 0, 2 and 1, 0, those are the points. And then you can extend that one using a ruler. So after doing that, so we have used these 2 points. Now the next question will be from your graph, that is part D, find the values of x which satisfy the simultaneous equations. So to solve that question, you can see you have 2 graphs. You have this graph and you have this one, the graph of the straight line. So you solve them simultaneously, and to do this you normally check where the 2 curves or the 2 graphs intersect, where the 2 graphs intersect. Where they're intersecting, they are intersecting at this point. So you read the x-coordinate of this point and this point. So the x-coordinate of this point and this point. So the x-coordinate of this point, if you drop down there, it will be -1. The x-coordinate of this point of intersection will be -1. So the first solution, x is -1. And then the second one, check the other point of intersection. The other point of intersection is this. So what is the x-coordinate of this point? The x-coordinate is 4. The x-coordinate of this point of intersection is 4. So you solve that. So part E, write and simplify a quadratic equation which is satisfied by the values of x where the 2 graphs intersect. Now to solve this question, you're going to equate the 2 functions. Is what I'm going to do. The first function is y is equals to 6 plus x minus x squared. So because the y values are the same, so the y function there, 6 plus x minus x squared, is equivalent to the second function is 2 subtract 2x. Remember, these are y function, that is the y function, and this one is the y function. So equate them like that in order to have one quadratic equation which satisfies the values of x where the 2 graphs meet. So from there, forming a quadratic equation, you just need to reorganize these values. So we'll have on the left hand side -x squared, and then plus x. I can bring -2x, which is on the right hand side, to the left hand side to have 2x. And then can also, so I have +6 on the left hand side. I can also bring +2 to the left hand side. I get -2, just reorganizing it to get 0. So this one will give -x squared plus 3x plus 4 is equals to 0. You can eliminate the negative coefficient of x squared by multiplying each value by negative. Multiply each value by negative, you get x squared, subtract 3x, subtract 4 is equals to 0. So that is the simplified quadratic equation which is satisfied by the values of x where the 2 graphs meet. Question 18. The table below shows marks obtained by 100 candidates at East Side High School in biology examination. So the marks are there and the frequency is given. Part A of the question, determine the value of x. Determine the value of x. So you can see x is where we have the frequency in this class, where we have 55 to 64. So to get the value of x, remember the total frequency, when you add the total frequency, which represents the total number of candidates, that should give 100, because there are 100 candidates. So the total frequency should be equal to 100. So the value of x is simply the number of candidates that are remaining in order to make this total frequency of the number of candidates to be 100. So the easiest way to get x is by taking 100, and then we subtract the sum of all the other frequencies in all the other classes. So we have 6 plus 14 plus 24 plus 14 plus 10 plus 6 plus 4. Whatever is going to remain will be the number of candidates in that class, that is x. So use a calculator to work out these. So 100 minus 6 plus, get that sum, and this one should give you, when you work it out well, this one should give 22. So this class has 22 candidates. Then you go to the other part B, state the model class. What is the model class? The model class is the class with the highest number of candidates or the highest frequency. So in all these classes, where do we have the highest number of candidates? It is 24. And which class is that? It is class 35 to 44. That is the model class. Part C, calculate the median mark. Calculate the median mark. So this is group data. So how do we get the median mark? So first of all, let me arrange this data in a way that will help me to work out the median, and also for the other part I can see you also require to get the mean. So let me draw a table here. So that is the table. So I'll have the class here, and then I will need the frequency, and then I will need the midpoint, which is x, and then I'll also require the cumulative frequency. So the classes, I can see the class size is 10. So the first one is 15 to 24. So 15 to 24. The other one is 25 to 34. The one is 35 to 44. The other one is 45 to 54. The other one is 55 to 64. Then 65 to 74. 75 to 84. Then 85 to 94. Then the frequencies are 6, 14, 24, 24, and then we have 14, 22, 10, then in 6 and 4 we have the last one is 6 and 4. So the midpoint, let us get the midpoint of all these classes. So the midpoint, like the first one, the class is of 15 to 24. So how do you get the midpoint? You simply take 15. So 15 plus 24 divided by 2. So this will give 39 divided by 2. That will give 19.5. And since the class sizes are uniform, in all these other classes, you don't need to keep on getting the midpoint. You notice that the difference will be 10. So like the other one, the midpoint for 25 to 34, you simply add 10 to 19.5. That will be 29.5. That is when you get 25 plus 34 divided by 2. Then the other one, you actually work the same. So this other one will be 39.5. The other one will be 49.5. 59.5, 69.5, 79.5, and 89.5. Those are the midpoints. Then the cumulative frequency. So the first frequency is 6. You add 6 plus 14, you get 20. 20 plus 24, that will give 44. 44 plus 14, you get 58. 58 plus 22, that will give 80. 80 plus 10, you get 90. Then 90 plus 6, you get 96. And then finally 96 plus 4, you get 100. Now, this one will help us to get the median mark. How does it help us? It will help us to identify the median class. So remember, the median class, the position of the median class will be given by n divided by 2, where n is the total frequency. So n, which is 100, then the median, you divide by 2, you get the position. So the position will be in the 50th student. So where do we have the 50th student? In which class? The 50th student is actually here. This is where we have the 50th student, where we have 58. The 50th student is in that class. So the median class, is 45 to 54. Now, having that, now we can get the median. So median, you get it by this formula, L plus n divided by 2, subtract cumulative frequency, then divided by frequency, everything multiplied by I. Now I'll explain what we mean by this. So what is L? L is the lower class boundary of the median class. So the median class is 45 to 54. So the lower class boundary is 44. You just take 45, subtract 0.5. So that will be 44.5. I repeat. So just take the class. The class is 45 to 54. So the lower class boundary of that class, from 45, simply subtract 0.5. Then plus, of course, n divided by 2, we have it here. So it is 100 divided by 2, you get 50. Then CF, the cumulative frequency above the median class, it is here, 44. The cumulative frequency above that class is 44. Then divided by F is the frequency of the median class. The frequency of the median class is 14. Then everything multiplied by I. I is the class size. So the class size, you get it by their uniform. So get the upper class boundary, which is 54.5. Then subtract the lower class boundary. I'm just using this class, 45 to 54. And this gives 10 as the class size. Now, after doing that, you can simply use a calculator to work out these. So this will be 44.5 plus, this will be 6 divided by 14 multiplied by 10. So use a calculator to work out these. So when you use a calculator, this is what you're going to get. So 6 multiplied, this will be 60 divided by 14. So this will be 44.5 plus, this is 4.286. Which gives 48.786. So that is the median mark. So the next question is the mean mark. Calculate the mean mark. Calculate the mean mark. So for the mean mark, there's something else that we require here. I'll require to introduce another column here, the mean mark. So I'll need another column for f of x. Why? Because to get the mean is given by the summation of fx divided by the summation of the frequency. So the summation of the frequency, of course, we have that because that is here. It is simply here. The summation of frequency is 100. It is 100. So we need this product. So use a calculator to work out that. F multiplied by x, 6 multiplied by 19.5, that is the first one. So 6 multiplied by 19.5, that will give 117. The other one is a 14 multiplied by 29.5, that will give 413. Then 24 multiplied by 39.5, that will give 948. Then the other one is 14 multiplied by 49.5, that will give 693. Then the other one is 22 multiplied by 59.5, that will give 1309. That will give 1309. And then the next one is 10 multiplied by 69.5, that will give 695. The next one is 6 multiplied by 79.5. So 6 multiplied by 79.5, that will give 477. It's 477. And then the last one is 4 multiplied by, this is 4 multiplied by 89. So 4 multiplied by 89.5, that will give 358. 358. Now after doing that, we can now get the summation. So now when you add everything here, the summation of fx, everything there, add everything from 117. So 117 plus 413 plus 948 plus 693 plus 1309 plus 695 plus 477 plus 358, that gives 5010. 5010. Now we have everything that we need. Now we have the summation of fx and then summation of f. So the mean, therefore, mean is given by the summation of fx, which is 5010, divided by the summation of frequency, which is 100, and therefore the mean will be 50.1. So that is how you solve that question. Question number 19. The figure below shows a metallic block with a uniform cross-section. Calculate its volume. Now when you look at this metallic block, it is made up of two shapes. There is the rectangular part, and then there is the top part, which is in the shape of a wedge. So we're going to get the volume of the rectangular part, and then we add the volume of the upper part, which is a wedge. So the volume of the rectangular part is given by the length times the width times the height. So we shall have 6 centimeters by 10 centimeters by 5 centimeters, and this will give 300 centimeters cubed. That is the rectangular part. Then we have the top part, which is a wedge, and for a wedge, to get the volume of that wedge will be given by the area of the cross section, multiplied by the length. The cross section is a triangle that measures 4 centimeters by 4, and then this side is 6 centimeters. So how do we get the area of that triangle measuring 4 centimeters by 4 centimeters by 6 centimeters? By simply using the Hero's formula. So we have 6, we have 4, we have 4. So we're going to use the Hero's formula. So, and the Hero's formula is given by S minus A, S minus B, S minus C. Then you get the square root, where we get S by adding the measurements, the 3 measurements, and then we divide by 2. 4 plus 4 plus 6, and then we divide by 2, which will give, this will be 14 divided by 2. So S is 7. So therefore, the area will be given by S, which is 7. Then 7 minus the first measurement, A, will be 6. So this is equivalent to A, this one is B, this one is C. So subtract 6, 7 subtract 3, subtract 4, I mean this is 4, then 7 subtract 4, we get the square root of that. This will give 7 multiplied by 1 times 3 times 3. This will give the square root of 63. So that is the area of the cross section. Therefore, now we can get the volume. So volume is given by, now of the wedge, the area of the cross section, which is the root of 63 multiplied by the length. The length will be 10 centimeters. So multiply by 10 centimeters. So the root of 63, you can get the root of 63, which is 7.9. This is 7.9, using a calculator, 7.937. So multiply by 10, this will be 79.37 centimeters cubed. Now we can get the total volume, the volume of the rectangular part. So total volume is given by the rectangular part, which we got as 300 centimeters cubed, and then we add the wedge, which is 79.37 centimeters cubed. So we get the volume as 379.37 centimeters cubed. So that is the volume of this metallic block. Now let's go to the surface area. Now it's surface area, the surface area. So for the surface area, we are going to get the area of all the surfaces that we can see. So as usual, we're going to begin with the rectangular part, which has how many faces are these? It has 1, 2, 3, 4, 5 faces. So I'll start with this face here. I'll start with this face. This face, the area of that face is 6 multiplied by 5. So 6 multiplied by 5. So 6 multiplied by 5, and then multiply by 2 because we have the other face on the other side. And then we have this face that is here. This one measures 10 by 5. 10 by 5. That is 10 by 5. 10 by 5, and then times 2 because of the other side, on the other side. So we're done with that. And then we have the bottom one, which is 10 by 6. 10 by 6. The bottom one is 10 by 6. 10 by 6. So what is remaining now? We go to the top part. For the top part, we have this rectangle here that measures 10 by 4. 10 by 4. And then there are 2 on the other side. So 10 by 4. So we have 10 by 4. 10 by 4. Then multiply by 2 because we have the other face on the other side. And then what is remaining now? The rectangular surfaces. And therefore the rectangular surfaces, we have the area of the surfaces. We got the areas of the rectangular surfaces as 7.937. So we multiply that by 2 because there are 2. So this now will give the total surface area. So we're getting the areas of all the surfaces. So these will be 30, these will be 60, plus these will be 50 times 2, these will be 100, these will be 60, these will be 80, these 40, these will be 80. Then for this one, 7.9, 7.9, and try to multiply these, multiply these. So 7.937 multiplied by 2, 15.874. 15.874. Now we can get the total. We can get the total. The total, we have 60 plus 100 plus 60 plus 80 plus 15.874. So this gives a 315.874 centimeters squared. So that is the surface area. Now, part C, the block was melted and recast into a cone of height 18 centimeters. Determine the radius of the cone formed. So this block was melted and recast into a cone. So there's one thing that we can get from that. If it was melted, if this metallic block was melted and recast into a cone, then the volume of the cone will be equal to the volume of that block. The volumes will be the same if it was melted and recast into a cone. So that means the volume of this cone will be equal to the volume of this block. And since we have the volume of this block as 379, so it will be 379.37 centimeters cubed. Now we need to get the area or the volume of the cone. How do we get the volume of the cone? We get it by not 2/3, but it is given by 1/3 pi r squared height. So we have 379.37, which is the volume of that cone, which is similar to the volume of the block, is equals to 1/3 times 22/7. We're using the pi, so 22/7, times the radius. We don't know the radius, so the radius squared, then times the height, which is 18. So what we need to do is just to make r the subject. So make r squared the subject of the formula, and r squared will be 379.37 multiplied by 3 multiplied by 7, everything divided by 22 times 18. So this one, r squared, will be given by, so this will be 379.37 times 21, that is 3 times 7, and then everything divided by 22 times 18. So you get r squared is equals to 20.12. So radius, that is radius squared, is equals to, so radius squared is equals to 20.12, correct for significant figures. So to get the radius, you get the square root of both sides. So the square root of 20.12, that will be 4.486 centimeters. So that is the radius of this cone. Hello and welcome. Let's solve this question on surveying techniques. A surveyor recorded the measurements of a maize farm in a field book as shown below. Take XY to be 400 meters, the baseline. All the measurements are given in meters. So information is there in that book, in the surveyor's book. Part A of the question: using a scale of 1 centimeter to represent 40 meters, draw the map of the field. So to do this, since you're given the baseline as 400 meters, you need to draw that one in centimeters, and given the scale here that 1 centimeter represents 40 meters, therefore for 400 meters as the baseline, we will have to draw 10 centimeters. So using this scale, 1 centimeter represents 40 meters. So what about 400 meters? So this one will be the baseline. So the baseline will therefore be 10 centimeters. So we start by drawing the baseline. So let me draw the baseline. So the baseline is 10 centimeters. So start from there. Oh, that's so big. Let me reduce that one a bit. So 10 centimeters, there it is. So that is 10 centimeters. So that is 10 centimeters. So the starting point here, this one will be X and this one will be Y. So you have these point is X and this one is Y. Now, the offsets that are to the right will be at the top of that line. Then the offsets that are to the left will be on the bottom of that line. So we have from X 80. So that will be 80 meters. So remember, these measurements are in meters. You have to convert them to centimeters using the scale. So for 80 meters, if you divide that by 40, you have 2 centimeters. So 2 centimeters. So 2 centimeters is what you're supposed to measure there. So 2 centimeters. Let me mark 2 centimeters. 2 centimeters will be here. So that is where we shall have 2 centimeters. So 2 centimeters will be there. So that is equivalent to 80 meters. I'll indicate the two measurements here so that you can see them properly. So this measurement here, so this is 2 centimeters and it is the one that is equivalent to 80 meters. Then from there, we go 200 meters to P, 200 meters to P. The offsets to the right, we said they will come at the top of that line XY. So 200, convert that to centimeters, so 200 divided by 40, that will be 5 centimeters. That will be 5 centimeters. So let me measure 5 centimeters. So 5 centimeters. So from here, and you should ensure that that one will be, all those measurements will be 90 degrees. Sorry, so that will be 5, like that. So that is 5 centimeters, which is equivalent to 200 meters, the top of that line. So let me indicate it there. So this is 5 centimeters, and that is what is 200 meters. So that is, this point is P, that is P. Then from there, we move to, from 80, we're moving to, so from 80, so this is X to this point, that is 80. Then from 80 to 200. So from 80 to 200. So what are we going to add there? From 80 to 200, we're going to add 120. So just get the difference. So 200 subtract 80. So you're going to add 120 there. So 120 divided by 40, because that is using the scale. That one I have to measure 3 centimeters. So from there, 3 centimeters. So from there, we have 3 centimeters. So let me measure 3 centimeters. So 3 centimeters. So 3 centimeters will be there. So let me mark it there. All right. So this distance is 100. Just to mark this distance is 120 meters, which is the same as 3 centimeters. You can see from X, we have 80, then plus 120, that will be 200. Then from 200, from this point, now we move to S, 160 meters to S, 160 meters to S. Now those are the offsets to the left. The offset to the left, we are going to put them below that line. So 160. What is 160? 160 meters using the scale, that will be 160 divided by 40. That will be 4 centimeters. So we measure 4 centimeters. So we measure 4 centimeters. Measure 4 centimeters. So 4 centimeters. That is what we want to get. So we measure 4 centimeters. So from that point, so 4 centimeters. So 4 centimeters is up to that point. So that is where we have point S. So this will be point S. So that is 160 meters, which is equivalent to 4 centimeters. Then from there, we go to 280. So up to this point, we are at 200. Now to 280, we are going to add 80. 80 is the same as using this scale. 80 divided by 40. So you're going to measure 2 centimeters. 2 centimeters. We measure 2 centimeters from there. So from here, measure 2 centimeters. So 2 centimeters will be that point. That point I've marked there. Then from there, so this one, let me first indicate this. So this is 80 meters, which is the same as 2 centimeters using the scale. Then from that point at 280, so at 280 we have 80 meters to R. 80 meters to R. 80 meters to R. That is to the left on the same side with S. So for this one, we are going to measure 80 meters will be 2 centimeters. That will be 2 centimeters. That will be 2 centimeters. So 2 centimeters. So from that point, so from there, that is 2 centimeters. So that will be 2 centimeters. So now this is R. This point will be R. And that point will be, that distance is 80 meters, which is equivalent to 2 centimeters. Still moving. So the next one from there is from 280, we go to 360. So from 280 to 360. So meaning from 280 we are adding 80 to go to 360. So we're adding 80. And 80 meters using this scale, 1 centimeter represents 40. That again will be 2 centimeters. So we're going to measure 2 centimeters again there. So we're going to measure 2 centimeters again there. So 2 centimeters. Very good. So this one. So 2 centimeters will be that point. You mark it there. This is a small one. That point. So this is the point. So that is the point. I want to indicate it there. So this is 80 meters, which is equivalent to 2 centimeters. So now we are at 360. And then at that point at 360, we move 80 meters to Q. 80 meters to Q. 80 meters equivalent to 2 centimeters. That is 2 centimeters. So on top of that, all right. So from here, so 2 centimeters. So 2 centimeters is up to that point. So now this is where we have point Q. That is 80 meters. 80 meters, which is the same as 2 centimeters. Now we're through. And then the last one, we have Y. So the remaining distance here will be given by Y. So what is the remaining distance? You can see this is 80 plus 120, that is 200. 200 plus 80 to 80, then 360. So automatically this distance here will be 40 meters because the whole of that distance XY is 400 meters. So now that is what you're supposed to have. And kindly ensure that all these are 90 degrees. Ensure that all these are 90 degrees. All these are right angle. That ensure that all these are 90 degrees. So now you can see the measurements can indicate those measurements here. So you can see, so this is the point where we have 80, that is 80. And then this is the point where from 80 went to 200, that point is 200. Then from 200, this point is 280. Then from 280, this point here is 360. And then lastly, this is 400. Now from there, you now join the point. So from X, you join this one using a straight line. Use a ruler to do this. So from X to P, then from P to Q. Sorry, from P to Q, you're joining these points. So from P to Q, and then from Q to, that is Y, like that. Then on the bottom of that line, again, you have to join using a straight line. So from X to S, like that. Then from S to R, and then from R to Y. So there we have the complete diagram with all the measurements indicated there. So now we're done with that part. That is how you're supposed to represent that information. The second question is find the area of the farm in hectares. Find the area of the farm in hectares. Now, as you can see, we have different shapes here. I will name these shapes. The first one here is a shape A. This one is a shape B. This one is shape C. This one is D. This one is E. And then this one is F. So to get the area, now you have to add the areas of all these. You have to add all these A, B, C, D, E, F to get the total area. So we start with the first one, A. You can do it here. So for A, I try to squeeze this one a little bit there. All right. So I want to use this space here. So for shape A is a triangle, and the area of that triangle will be a half times the base, which is 80 meters, times the height, which is 200. So this gives by 2, 1 by 2, 100. This one will give 8,000 meters squared. We go to shape B. Shape B is trapezium. The area of a trapezium is half multiplied by the sum of the two parallel sides. The two parallel sides are this one, so 200 and 80. 200 plus 80. So this will be 200 plus 80 times the height. The height is this distance from this point all the way to this point. So we have 120 plus 80, that is 200. then plus 80, that is 280. So this will give, you can work out this by 2, 1 by 2, this one is 140. So this will give 200 plus 80, that is 280 times 140. That will give 39,200. Then we come to C. Shape C is a triangle. I have base times height. A half times the base. The base is 40 meters times the height. The height is 80 meters. 1 by 2, 20. This will give 1600 meters squared. Then for shape D, this one is a triangle as well. So this will be a half times the base. The base is 80 plus 120. That is 200. And then the height is here. The height is 160. So this will give 16,000 meters squared. We go to shape E. Shape E is trapezium. The area is half times the sum of the two parallel sides. The sum of the two parallel sides are, we have 160 plus 80. That is 240 times the height. The height is 80 by 2, 1 by 2, 120. So this will give this 9600 meters squared. Then for shape F, F is a triangle, a half times the base. The base is here, so the base is 80 plus 40, that would be 120 times the height. The height is here, 80 meters. Using 80 meters, we're using the meters, 80 meters. So by 2, 1 by 2, this is 60. So this will give 4800 meters squared. Now, after doing that, now the next thing is getting the sum. We simply get the sum of everything. So we shall add everything here. We add everything and we get the total. So this will give the total area. So we add everything using a calculator. So we have the first one, which is 8,000 plus 39,200 plus 1,600 plus 16,000 plus 9,600 plus 4,800. We get 79,200. So 79,200 meters squared. We're supposed to give that in hectares. So convert that in hectares. Now remember that 1 hectare is equivalent to 10,000 meters squared. Therefore, you're going to divide these by 10,000, these meters squared by 10,000 in order to get the hectares. So when you divide these, you will get, these are 4 zeros, 1, 2, 3, 4. This one will give 7.92 hectares. So you get 7.92 hectares. And that is how you're supposed to solve that question. Question 21. A businessman is paid a commission of 5% on sales of goods worth over 100,000. He's paid a monthly salary of 15,000, but 2% of his total earning is remitted as tax. In a certain month, he sold goods worth 500,000. Part A, calculate his monthly net earnings that month. So the first thing that you begin to get is this commission. But he gets a commission of 5% of goods that are over 100,000. In that month, he sold goods worth 500,000. So what are the value of the goods that are above 100,000? We do that by taking. So we want to get goods above 100,000. That is what you want to get. And this one we get by getting the total sales, which were 500,000. Then subtract, those are the sales. Then we subtract 100,000. So the goods that were above 100,000 were valued at 400,000. So the commission now will be calculated. These are 5% of goods over 100,000, which is 400,000. And this will give, so this one will give 20 3. So that will give 20,000. So that will be the commission. Then on top of that, he gets monthly salary of 15,000, monthly salary of 15,000, and 2% of his total earnings are remitted as tax. So now the total earnings would be given by, we have the commission that he got, which is 20,000 plus salary, which is 15,000. So get total sales of 35,000. So that is now what he gets as the total earnings. Then from there, something else is on tax. So tax, that is a 2%. 2% is remitted as tax. So we need to get the tax. So 2% means this will be 200 multiplied by the total earnings, which is 35,000. So this one gives 700 shillings. So that is the tax. Now to calculate his monthly net earnings for that month, we simply get the total earnings. So net earnings will be given by 35,000, then subtract the tax. So 35, and this will give 003. So you get 34,300. So that is the amount that he gets as the net earnings for that month. So that is all about that part. We go to part B. Now the following month, his monthly salary increased by 20%. His commission was also increased by 10% to 10%, but on goods worth over 200,000. If his total earnings that month was 64,800, calculate the money received from the sale of the goods. So the first statement here, he got an increase of pay. So monthly salary was increased by 20%. So what would be the new salary? So the new salary would be 120%, because it was increased from 100% by 20%. So the new earnings will be 120%. That is 120% of 100, then multiply by the monthly salary was 15,000. It was 15,000. It is here in the first part. So we want to get 120% of that. So 15,000, and this will give 18,000. So that is the new monthly salary. So from 15,000 to 18,000. Then from there, his commission was also increased to 10, but now that will be on goods worth over 200,000. Then we given that the total earnings that month, total earnings was 64,800. Calculate the money received from the sale of goods. So we actually require to get the total sales. Now for this part of commission, because we don't know the goods that were above 200,000, we can let the goods, so let goods above 200,000 be N and shillings. So if it will be represented by N, so if we get the commission now, the commission will be given by, the commission is 10%, so it will be 10 over 100 multiplied by N. N now represents the value of goods that are above 200,000, because we don't know the goods that are above 200,000. And this will be given by 0.001. 0.1. So these 0.1n, these will be the commission. Now, if his total earnings that month was 64,800, and these are total earnings, remember, the total earnings will be represented by the basic salary, which is 18,000, plus the amount gained from commission, which we found is 0.1, and that is what represents the total earnings. And then to get the total earnings, remember there's another condition here, that there's a taxation. This taxation from the first part, 2% is remitted as tax. So these total earnings will be given after taxation. So the taxation is on the total earnings, 2% of the total earnings. So if these are the total earnings is represented by 18,000 plus 0.1n. Therefore, the tax will be represented by, remember the tax is 2%. So that will be 2/100 of the total earnings. The total earnings is 18,000 plus 0.1n. So we can simplify this on. We can simplify these. So we can simplify this one very fast here. So we have 2%, that is 0.02. So this will be 0.02, 18,000 plus 0.1 n. So this will be the tax. That will be the tax. So once you open the brackets here, 0.02 multiplied by 18,000, that will be 360. It will be 360 plus for this one will be, so we have confirm something here. So 0.02 multiplied by 0.1. Of course, this one will be 0.002 n. So now this is what represents the tax. 2% of the total earnings. Now these earnings that we're given here, which is a 64,800, is the amount now after total earnings subtract the taxation. So total earnings. Will be given by, we have the earnings which are given by 18,000 plus 0.1 n, that is the basic, the salary plus the commission, and then we subtract the tax. The tax is here. We got the tax as 360 plus 0.002 n, like that. That is what is going to give us this figure, 64,800. So this represents the earnings, and this is the tax. So now we can remove the brackets here and simplify. So this will be 18,000 plus 0.1 n, subtract 360, subtract 0.002 n is equals to 64,800. So from there, let me collect the n, 0.1. So 0.1 subtract 0.002, that will give us 0.098 n is equals to, so have 64,800, take 360 to the right hand side, you get plus 360. Remember, we are making n the subject, and then subtract 18,000. I think that one is okay. So this will give 0.098 n is equals to 0. So you're making n the subject. So 0.098 n is equals to So let me work out these as 64,800 plus 360, and then subtract 18,000. So that gives 47,160. So divide both sides by 0.098. So divide by 0.098. So this gives 481,224.49. That is 49 cents. So this is N. And remember, what was N? N were goods above 200,000. Goods above 200,000. Therefore, now the total sales will be given by, because N refers to the value of goods above 200,000, we are going to take 200,000 plus. Now N, which is the value of goods that are above 200,000, that is a 481,224.49 cents. And this gives, so plus 200,000. This gives the value of goods sold as 681,224.49 cents. So that is actually the total earnings that month. And actually that is how you're supposed to solve that question. Question 22. Triangle ABC and A prime, B prime, C prime are drawn the grid. So you can see the two triangles there. So let us go to the first question. Describe fully a single transformation that maps a triangle ABC onto triangle A prime, B prime, C prime. So you can see the two triangles. So triangle ABC is here, and then it is mapped onto these. So you're actually required to describe a single transformation that maps this triangle here, smaller one, to this one. So think of all the transformations, but the one that is evident in this question, because you can see the change in size, is actually enlargement. And that is actually the transformation, because you can see triangle ABC is small, and you can see triangle A prime, B prime, C prime is a larger one. So it has been enlarged, and therefore the transformation is enlargement. Now, how do you describe an enlargement? You describe an enlargement fully by giving the center of enlargement and the scale factor of the enlargement. So how do we get the center of enlargement? We begin with that. Now, the first thing we're going to do is joining. You can join, you can say to join either point A, you join it to A prime, and then you can decide to join B to B prime. So let me start by joining A to A prime. So joining A to A prime. So you have A is there. So I join that one to A prime like that. And then I join, or can join even C. You can choose any point that you wish. I can even decide to choose C. So let me choose C to C prime like that. Now, where those lines meet, that is the center of enlargement. The two lines connecting from object point to the image point. So I've joined A, that is the object point, to A prime, that is the image point, and then I've joined C to C prime. So that is the object is C, image point is C prime. Where the two lines are meeting, that is the center of enlargement. So the center of enlargement is the origin, which is O. Now from there, let us get the scale factor of enlargement. Scale factor of enlargement. So how do you get the scale factor of enlargement? Now to get the scale factor of enlargement, you can get this measurement from C, for example, from C to O, and then O to C prime. So I'll take this distance O, I'll take the distance O to C prime divided by OC. Or you can take OA prime divided by OA. Either of these will give you the scale factor of enlargement. So I'll use this distance O to C prime, O to C prime. That is what I'm going to use. So O to C prime, this is the distance. So from this point to this point. So you can take that measurement. You can use a ruler to do that. So let me take that measurement. So I can see that is 3.4, that is 3.4 according to my measurement here. OC prime is 3.4, and then I take the other measurement, OC. So O to C is this measurement. So from this point to this point, I can see that one is 1.7. So divided by 1.7, and this one gives you 34 divided by 17, it will give you 2. So that is actually the scale factor of enlargement. Now, the other thing that you need to notice here is that the scale factor of enlargement will actually be negative. Why will it be negative? Because in negative enlargement, the object and the image are on the opposite sides of the center of enlargement. So look at the center of enlargement. The center of enlargement is the origin, it is here. Then the object and the image are on the opposite sides of the center of enlargement, and that one is why we give the scale factor of enlargement as negative. If the object and the image are on the same side with the center of enlargement, they are on the same side, that is the center of enlargement, the object and the image. If you find them on the same side, that is positive enlargement. But in case you find the object and the image are on the opposite sides of the center of enlargement, then that one is definitely the negative scale factor of enlargement, and therefore this one is negative 2. So now we can describe that. So this one is an enlargement, that one is an enlargement. Center is the origin, and then the scale factor of enlargement is negative 2. That is the full description of an enlargement. Now you can go to the next one. The next part is on the same grid, that is part B. On the same grid, draw one triangle A double prime, B double prime, C double prime, the image of triangle A prime, B prime, C prime under a rotation of positive 90 about the origin. So now we're supposed to get the image of A prime, B prime, C prime. So when you go to the diagram, I will first need to clear this. So I will clear this one so that I can now rotate. So you're required to actually rotate this one, A prime, B prime, C prime, under a rotation of positive 90 about the origin. Positive 90 about the origin. So how do you go about that? I'm going to use a protractor, and I'll use a ruler and a pair of compass to do that. So the first thing you do, you're supposed to join every point to the center of rotation. The center of rotation is the origin. So I'm going to begin with A. So point A is there. So begin with point A. I join it to the center of rotation. Then from there, positive 90 degrees. I want to rotate that through positive 90 degrees. So I'd like you to observe how I'm going to place my protractor. So on that line, that you can ensure that the central part of the protractor is the origin there. And then look at the way this protractor is supposed to be aligned like that along this straight line, like that. So that is how you place it, and actually ensure that this is the central part of the protractor. This is a straight line. Then positive 90 degrees, you're going to measure that one in anti-clockwise direction. Anti-clockwise direction mean you're going to measure it from this way, from this point going this way up to 90 degrees, like that. So you measure 90 degrees. So this is what I'm going to draw. So 90 degrees, you can see that is 90 degrees. You measure 90 degrees, so that is 90 degrees. You can see that this point here. So from this point 0 all the way to 90, that is anti-clockwise. That is positive 90 degrees. That's how you measure it. So you draw that line there. So this is 90 degrees. Then from that, this is what you do. Now you need now to take a pair of compass and take this measurement. So from A, you take that measurement A to the center, that is to the origin, the center of rotation. So from A, you take that measurement. So take that measurement there. So take that measurement from A to O, and then transfer that one to, you started that O, and then you transfer that line that you've drawn there and C. So that is where you're supposed to, mark an arc. So that is just a small one, small one, that you mark that, and these will be A double prime. So these will be A double prime. Now we go to B, join B to the origin, join B to the origin using a straight line. So B to the origin like that, and then from there you measure 90 degrees. So this is how you place your protractor, the central part of the protractor, and then you place it along that line, and ensure like that. So that is I want you to note how you place that. So you can see how I've placed the protractor. The central part of the protractor is there. So you measure 90 degrees, so measure 90 degrees, and you draw, so 90 degrees. So you can see that is actually 90 degrees. Measure 90 degrees. So this is the angle from this point, or that is positive 90 degrees. Then from there, the next thing you do is actually taking the measurement. Take this measurement here. So take this measurement from B to the center, that is from C to O, from B to O, I'm sorry, from B to O, take that measurement, and then transfer that measurement, stand at the origin, and then you transfer that measurement there. So you mark an arc. So that will be point, or the image of B, that is B double prime. So this will be B double prime. You can see this distance, B to O, that is the distance you've taken, and then you start at this point to B prime. So for A, we took this measurement from A to O, and then we transferred that distance, that is the distance there, we marked A. So the last one is C. So from C to the origin, you join that. Then from there, you measure these, place your protractor and measure 90 degrees. So you can see the way I've placed it. So I've placed it, this is a straight line there. I want to measure now 90 degrees from this line, 90 degrees. So measure 90 degrees. So from that point, so 90 degrees is there. So that is 90 degrees. Now this angle here, what is that? This angle from this point all the way to that line, that is a line 90 degrees. So once you've done that, now it's time to take that measurement. So you take this measurement from C to O, and then you transfer that by marking an arc there. So you've taken that measurement. So the measurement is here. You've taken this measurement C to O, then you've transferred that. So this is the image of C. So this is C double prime. So now you have the 3 points. So you have A double prime, B double prime, C double prime. You can join them to make that triangle. And join them. So from A to B, and then from B to C, and then from C to A. So that is the image. You've done that. So we've now given triangle A double prime, B double prime, C double prime. The triangle is there. 2 marks. We go to the next part. The next part is triangle A triple prime, B triple prime, C triple prime. The image of triangle A double prime, B double prime, C double prime, and a reflection in the line y is equals to negative x. Now that triangle that we've drawn, this triangle, I can name this triangle for the purposes of identification. So I can name this triangle A, this being triangle B, and this triangle C. So triangle C, that is triangle A double prime, B double prime, C double prime. You need to get the image of that and a reflection in the line y is equals to negative x. So y is equals to negative x is this line that passes through this point. Let me draw that line. Y is equals to negative x. Y is equals to negative x. We have this line that passes through this point. That is the line that passes through the center of the axis. So this is actually y. This is y is equals to negative x. So you need to give the image of that, and this is what you're supposed to understand. Before you draw that, there's one thing that you need to understand, that under a reflection in the line y is equals to negative x, if you have the object point as AB, that point you get the images as negative B, negative A. So the points are reversed and they also change the signs. So it is easy to get the images of these points. So under that, A double prime is this is 8, 2, 8, 2. So that one becomes a triple prime, that becomes -2, -8. Then for B double prime, B double prime is a 6, 6, 6, 6. So that one B triple prime, so that one B triple prime becomes -6, -6. The points are reversed and they also change the signs. Then for C double prime, we have 2, 4. That is 2, 4. That is 2, 4. And that one becomes -4, -2. Now, having that, we can simply now plot them to have that triangle. So for A triple prime, -2, -2, -8. So -2 is here. Then -8 will be here. It will be here. So these will be A triple prime. And then for B, -6, -6 be here. This is B. And then for C, -4, -2, -4, -2. So this is a C triple prime. So now we can join them. We can join them. So we have A dot B, and then from B to C using a straight line, and then from C D. So that is the triangle. Actually, you can see now the object and the image. You can see. So this is the triangle. After it has been reflected in that line, y is equals to -x, we get it here. So that is basically how you're supposed to solve that part. We go to the last part. Draw the line, that is part C. Draw the line of symmetry of triangle A prime, B prime, C prime, and hence determine its equation in the form y is equals to mx plus c. Draw the line of symmetry of triangle A prime, B prime, C prime. Which triangle is that? It is this triangle. This triangle. Draw the line of symmetry. The line of symmetry is the line that divides that triangle into two equal halves. And when you look at this triangle, you notice that it is isosceles. It is isosceles. So this side is equivalent to this side. And therefore, to divide it into two equal halves by that line of symmetry, we will need to get the midpoint of AC. Get the midpoint of AC. So the line that will pass through the center at this point, So the midpoint, we need to get the midpoint of A prime, C prime. So I will take that measurement. I'll take that measurement using a ruler so that I can know exactly the midpoint. Let me take the measurement and take that measurement. So that one is around 4.8. 4.8. That is 4.8. So therefore the midpoint will be, that will actually be 2.4. So 2.4. So 2.4, let me draw that line. So 2.4. So from this point, here, so from this side, so from this point, I will have to draw, let me check first. So from this point, so I will need to mark 2.4 here. Let me mark 2.4. So 2.4 is here, somewhere here. So I will need to draw a straight line using a ruler from this point C. So let me first clear. I'll need to clear these. I need to clear something here, or I can just continue with that. I don't think there's any problem. I can just continue with it. So I actually want to draw the line. So from this point, so that will be the line of symmetry. That will be the line of symmetry. So what I've done, I've actually taken the measurement. So these are this point. So these A prime to C prime, I've got them to be 4.8. I've taken the midpoint of that, that is 2.4, and this one is 2.4. So because this one is an isosceles triangle, if I draw a line from this point straight, it will divide that triangle A prime, B prime, C prime into two halves. So you can see this triangle has been divided into two halves by that line. So there's this half on this side and there's this half on this side. So I've just taken the midpoint of this line, A prime, C prime, because this side and this side is equal, and it is an isosceles triangle. So that is the line. So this is the line of symmetry. Now what we require to get is the equation. We actually need to get the equation of that line. So to get the equation, we actually need just 2 points, on that line, and identifying these points is very easy. So we have the first point is here. This is point B, which is a 6, -6, 6, -6. And then I have another point here, this point, just 2 points on that line, any 2 points. This is 0, -4. So this is 0, -4. So these 2 points can help me get the equation. So I start by getting the gradient. The gradient of that line will be given by change in y, which is -6, subtract -4, divided by change in x, 6, subtract 0. So this will be -6 plus 4 divided by 6, and this will be -2 over 6, which is -1/3. So -1/3 is actually the gradient. Now, having the gradient, I can simply use the gradient, and I can introduce, I can simply use 0 and -4, and then I introduce another general point on that line, x, y. So I have the gradient, which is -1/3. So change in y, so y subtract -4 divided by change in x, x subtract 0 is equals to -1/3. So this will give y plus 4 divided by x is equals to -1/3. Is still moving on. So this will give, if you cross multiply, you get 3 multiplied by y plus 4 is equals to -1 times x, that is -x. So this will give 3y plus 12 is equals to -x, like that. And then supposed to give the equation in the form y is equals to mx plus c. So therefore 3y is equals to -x, subtract 12. So divide both sides by 3, or each value by 3. Y is equals to -x over 3, then subtract 4, 12 divided by 3. So that is the equation of that line of symmetry in the form y is equals to mx plus c. And that is how you're supposed to solve that question. In the diagram below, PQ is equals to 9 centimeters, PS is equals to 7 centimeters, RS is equals to 3.1 centimeters, and PR is equals to 7.5 centimeters. Angle QPR is equals to 50 degrees. So in the diagram, you can see all the measurements are given and the angle. First question, calculate the distance from Q to R. Q to R, you can see in the diagram, Q to R. Now, how do we calculate that distance? Now, to calculate that distance, I will consider triangle PQR. So that is the triangle that I'm going to use that will help me get that. So look at triangle PQR. Now, in triangle PQR, you're given 2 sides and an included angle. The 2 given sides are PQ, which is 9 centimeters, and PR, which is 7.5 centimeters, and an included angle, which is 50. Now, in this case, you need to think on all the methods that you can use to solve the triangles. Of course, you're not going to use the trigonometric ratios because you don't have right angle triangle anywhere here. Think of the sine rule, think on cosine rule. So where you're given 2 sides and an included angle, and you're required to get the other side, the best method is to use the cosine rule. So we shall use the cosine rule to find QR. So to do that, I will name this side opposite R as small r, then this side opposite P as small p, and then the side opposite Q as small q. The cosine rule, ensure you are familiar with the cosine rule. Now, the cosine rule states in this particular, using this particular triangle here, we want to get the side QR, which I've denoted with small p. So small p. So p squared, this is a cosine rule, is equivalent to r squared plus q squared. That is the sum of the squares of the 2 given sides. Then subtract 2 multiplied by r multiplied by q, then multiply by the cosine of the included angle, which is 50 degrees. So let me work out this. So r squared is, this one is 9 squared plus q squared, that is 7.5 squared. Subtract 2 multiplied by r, which is 9, times q, which is 7.5, multiplied by the cosine of 50 degrees. So from there, you can use your calculator to work out these. So I'll start with 9 squared. So 9 squared plus 7 squared. This will give 137.25. Then subtract 2 times 9 times 7.5. 2 times 9 times 7.5. That will give 135. Then multiply by the cosine of 50 degrees. From this stage now you can work out everything. 137.25 subtract 135 cosine of 50 using a calculator. You'll get this one is 50.47. So that is p squared. So p squared is equals to 50.47. So how do you get p? By getting the square root of both sides. Square root of p squared is p. The square root of 50.47 will be 7.104. That is correct to 4 significant figures, centimeters. So that is the distance from Q to R. Part B, the size of angle Q. The size of angle Q. The size of angle Q. So you're required to get this angle. So that is the angle we're required to find. So this is a 7.104. Now to get the size of angle Q, once again, you need to think between a cosine rule and the sine rule, which one is best to use here and the easiest. For this one, I will use the sine rule. I will use the sine rule since I have one angle and the given side. So from this triangle, the sine rule, I will have P divided by sine of P. So P divided by the sine of P, this is the sine rule, is equals to Q divided by the sine of Q. Q divided by the sine of Q. So I have P. I've just obtained P as 7.104. Then the sine of P. The sine of P, the angle at P is 50 degrees, is equals to Q. Q is already there. At the side Q, that is 7.5. That one is 7.5 divided by the sine of angle Q. So that is what I'm looking for. So from here, I will make sine Q the subject of the formula. And sine Q will be given by, if you cross multiply here, you get sine Q is equivalent to 7.5 multiplied by sine of 50 degrees, everything divided by 7.104. So this one will give sine of Q to be, if you divide that, this is 7.5 sine 50, that will give 0.8087. So now to get theta, that angle, the sine of Q, this is Q, this is Q, that is the angle. Let me just indicate the way it's supposed to be Q, the sine of Q. So Q will be given by, if you get the sine inverse of 0.8087, that will give, using a calculator, 53.97. 53.97 degrees. So that is how you work out the size of angle Q. Now the other one is the size of angle RPS. The size of angle RPS. So why is RPS? RPS. So this is the angle here. That is the angle. So RPS. So for that one, you're going to consider triangle PRS. In that triangle PRS, we don't have any angle given, but we have all the sides given. So we can use the cosine rule there. I will name this side here as P, small p. Then the other side here is R, small r, and then this one is S. So from that triangle PRS, I will use the cosine rule. And cosine rule will be like this, P squared. So P squared is equals to the sum of the squares of the two given sides. That will be 7.5 squared plus 7 squared, 7.5 squared. So 7.5 squared plus 7 squared, then minus 2 multiplied by 7.5 multiplied by 7 centimeters, then multiply by the cosine of P, because we require that angle P. So that is the cosine rule. Ensure that you know very well how to use this formula given any triangle with two given sides, or maybe in a case where you're required to get the angle, like in this question. So from here, you have P squared. I would simply substitute. P squared is 3.1 squared. So that one is 3.1 squared. Let me substitute this one with 3.1 squared, so that you can do this one quickly. So 3.1 squared, like that. So now you can use the calculator from here. So from here you can use the calculator. So 3.1 squared, very fast, this will give 9.61 is equals to 7.5 squared plus 7 squared. That will give 105.25. Then subtract 2 times 7.5 times 7, that will give 105. Then cosine of P. So from here you can make P the subject. So I can decide to take this one to the left hand side, and then I can take 9.61 to the other side. So this one will give 105 cosine of P is given by this one will be given by 105.25 minus 9.61. So this one you get 105 cosine of P is equals to, when you get that difference, 105.25 minus 9.61, that will give 95.64. 95.64. So dividing both sides by 105, you get 95.64 divided by 105. That will give 0.9109. So to get P now, get the cos inverse of both sides. Cos inverse of cos P, we get P. The cos inverse of 0.9109, that will give 24.37 degrees. That is all about part C. Then the last one, the last question, the area of triangle PQS. The area of triangle PQS. So what is PQS? PQS is the bigger or the larger triangle. Now for that one, since we have the angle, as long as we have two given sides and an included angle, we can solve this one so easily. So I'll use the angle at Q, because we already have the angle at Q. The angle at Q is given, it is a 53.97. So I can use this formula. Area is equals to a half times AB sine theta. So AB is the two included sides, and this will be a half times the two given sides. The first side, I want you to be very keen here. The first side is a QS. QS is 7.104 plus 3.1. This will be 10.204. The whole of this length, the whole of that length, that is QS, 7.104 plus 3.1. That will be 10.204. 10.204 times the other side between the given angle. The other side is QP, which is 9. QP, which is 9. Then times the sine of the angle between those two given sides that we have used, which is angle Q. We got that one to be 53.97. 53.97 degrees. So for this one, you simply need to work out this one using a calculator, and then you get the answer. So very fast, key in everything. Half times this 10.024 times 9 times sine of 53. This one will give 37.13 centimeters squared, and that is how you're supposed to solve that question. In the figure below, P, Q, R, S, and T lie on the circumference of the circle center O. Line UPV is a tangent to the circle at P. Chord ST of the circle is produced to intersect with the tangent at U. Angles UPT, RST, and ORQ are 28, 100, and 50 degrees respectively. So the diagram is there. You can see all the angles indicated. Now the first part of the question, determine the sizes of the following angles. The first one is RTP. So we identify that angle first, RTP. The diagram, RTP is this angle. So that is the angle that we need to get. Now while solving this question, you need to be familiar with most of the angle properties of a circle. Otherwise, it will become very difficult if you've not gone through all the properties relating to circles, chords, and tangents. So let us go through. I will be giving the reasons for the answers I will be getting for all these angles. So like for this one, when I look at this diagram and all the angles that are given, there are angles that I can be able to feel. The first one, I look at this tangent VPU, that tangent, and then you have this angle here is 28. So when you look at this angle, which is 28 here, and this is a tangent, there's another angle. I'll be able to get this angle. So this angle that is here, and I'll give the reason for that. So angle TPU is equals to, that will be the same as angle TQP, angle TQP, and that one, both of them are 28 degrees. Reason, these are angles in the alternate segment. Angle TPU, which is 28 degrees, is equals to angle TQP. So this angle is 28 degrees as well. After getting that, I'd like you to look at this quadrilateral. So quadrilateral RSQT, RSQT. And I'd like you to look at this angle that is here, this angle S and angle Q. Those are two opposite angles in a cyclic quadrilateral. And the property relating to that is that the sum of two opposite angles in a cyclic quadrilateral should be 180. And therefore, let me first write this. So angle RST is equals, not is equals, but plus angle RQT plus angle RQT. That one should give 180. And therefore, if this S is 100 degrees, then this one should be 180 minus 100, and this one will be 80 degrees. Now, once we've done that, there's something else that I can do. Now, look at the center RO. O is the center of the circle. And let me see whether so far I'll be able to get angle RTP. Yes, I can be able to get that by considering these quadrilateral. So consider this quadrilateral RTQP. RTQP. Look at that quadrilateral. And then you look at this angle RQP. Angle RQP plus angle RTP. Angle RTP, that is the required angle is supposed to get. That one you should get 180. Again, these are opposite angles in a cyclic quadrilateral. The quadrilateral is RTPQ or RTQP. RTQP. So that is the quadrilateral. And when you get the sum of the opposite angles in that cyclic quadrilateral, you should get 180. And therefore, the whole of this angle Q is 80 plus 28. That will be 108. So we're going to get 180 degrees, subtract 108 degrees, and this one should give 72. So the whole of this angle is therefore 72 degrees. So we have already obtained that. So that angle is 72. In case you're required to give the reason, you could have given that reason. These are the sum of two opposite angles in a cyclic quadrilateral is 180. The other question is question part 2, QTP. QTP, angle QTP. So which is that angle? Angle QTP. So angle QTP is a QTP is this angle that is here. Is this angle that is here. So how do you get that angle? To get that angle, I'll try to join. If I join from the center, so from the center, let me make this one smaller. So from the center here, center O, if I join that using a straight line, so I draw a straight line from center O to T, there is an angle here I can get, and the angle is, look at this angle. If we have the angle subtended at the center here, this angle subtended at the center here, let's look at it. The angle subtended at the center here is twice the angle subtended at the circumference by this chord RT. The angle subtended at the center by this chord RT. This chord RT subtends 100 degrees at the center. So this angle at the center here should be twice the angle subtended at the circumference. So if the angle subtended at the circumference is 100, then this angle should be twice that, should be 200 degrees. So if that angle is 200 degrees, then the other one that is here, this angle should be, because of the sum of angles at a point, this angle should be 160 to make 360. So 200 plus 160, 360. Again, this is isosceles triangle. So if this angle is 160, then this angle should be 10 degrees. And then this one is 10 degrees because this one is forming an isosceles triangle. So this angle here, 10 degrees, then this one is 10, then this one is 160. Now, I think with those angles that are filled, I'll be able to get this angle now. QTP is this angle that is here. I'll be able to get this angle. Let me first rub this one so that I can rub that on so that I can be able to indicate this angle clearly. The angle that is required is this. This is the angle. So again, I would like you to look at this quadrilateral. So RQPT. That is another cyclic quadrilateral. And the opposite angles, two opposite angles are supposed to add up to 180. So this angle, I'll indicate it here. So angle QPT plus the other angle is QRT. That one should give 180. So those two angles, and you have this angle at there is a QRT. QRT is a 50 plus 10, that would be 60 degrees, and that one tells us that this angle, we'll be able to get this angle. This angle should be, that is angle QPT, this one should be 120 degrees. So this angle here should be 120 degrees. Now having that, it is easier now to get angle QTP. QTP is here. We are going to consider this triangle QPT. Triangle QPT. We have 120. So we have 120. And then we have 28 degrees. That gives 148 degrees. So the sum of angles, interior angles in a triangle should give 180. So we get the remaining one. We just take 180, subtract 148. And that one should give 32 degrees. So this angle here is 32 degrees. So we have given the two angles. Now you can see that we are using all the properties of angles that we know to get the angle. So those are the two angles. RTP 72 and then QTP 32 degrees. We go to the other part. Part B, given that PQ is equals to 6 centimeters, calculate correct to 1 decimal place the radius of the circle. PQ is given here. PQ is 6 centimeters. So it's supposed to give the radius of the circle. Now, because these I'm going to extract that triangle QPT. I will extract that triangle QPT. So triangle QPT. Let me extract these. Triangle QPT. So PQ is 6 centimeters. And then we have the angles 120, 28, 32. 120, this is 120, this is 28 degrees, and this one is 32 degrees. So you're supposed to find the radius of the circle. Now, how do we find the radius of the circle? There is a concept that we need to understand before we solve that question. You can see that this triangle is circumscribed. There's a circle that is circumscribed onto that triangle. There's a circle that is touching the 3 vertices of that triangle. And if you recall about the sine rule, recall about the sine rule, we can use the sine rule to get the radius of the circle. And this is the sine rule. Just to remind you, A divided by sine A is equals to B divided by the sine B is equals to C divided by sine of C is equivalent to 2 radius. This is the concept that we need to use in order to get the radius of the circle. Now, we don't need to have all the angles and all the sides. We simply need to get a side and an angle. And when I look at what we have here, I can use that side QP, and then the angle that is the opposite, that is 32. So from these, I can get 6 divided by the sine of 32. That one should be equal to 2 radians. That is what you're going to use. Simple as that. And this one should give, so 6 divided using a calculator, 6 divided by sine 32, 6 divided by sine of 32, that gives 11.32. That is correct to for significant figures is equals to 2 radians. So divide both sides by 2 to remain with R. So if you divide this one by 2, you get this one is 5.66. So correct 1 decimal place, you get 5.7 centimeters, and that is the radius of the circle. That is how you're supposed to solve.